हेलो। हेलो। आशीष, आवाज आ रही है? हेलो। आशीष। सुधांशु, आवाज आ रही है? कोई रिस्पॉन्स नहीं कर रहा है। हेलो सुधांशु। हेलो। सुमन कुमार। Am I audible? हेलो। So just allow some students are in waiting, then we will continue to the class. Sudanshu, am I audible? Hello. सूरज प्रकाश। हेलो।
Yes, sir.
आवाज आ रही है?
Yes, sir.
कोई रिस्पॉन्स क्यों नहीं कर रहा है? So today we are going to discuss parallel operation of three-phase transformer. Okay. So we just try to perform in the laboratory how we can two transformer connected in parallel. Okay. So first of all, why we require two transformer connected in parallel? Can you just tell me why we require to connect the two transformer in parallel? Why we require the two transformer connected in parallel? Just tell me. What are you think about this? दो ट्रांसफार्मर को हम लोग पैरेलल में कनेक्ट करने के लिए क्या जरूरत पड़ेगा? क्या एडवांटेज है? Hello.
Yes, sir.
दो ट्रांसफार्मर को हम लोग पैरेलल क्यों कनेक्ट करना है?
लोड कैपेसिटी बढ़ाने के लिए सर।
लोड कैपेसिटी बढ़ाने के लिए।
यस सर।
और अदर कोई एडवांटेज? फिर कनेक्ट टू ट्रांसफार्मर पैरेलल। Any other advantage for increasing the capability of power supply?
सर अगर एक ट्रांसफार्मर ये हो गया बंद हो गया तो दूसरे ट्रांसफार्मर से हम लोग लोड को रन करा सकते हैं।
Exactly. At least we are not able to supply the rated power, but at the reduced power we can supply to the load whatever the capacity of one transformer which is under running condition. Other transformer if create fault, then we can disconnect more frequently, and power supply is frequently increase, not interrupted due to the one transformer create fault. Is not. And one more advantage one has to mention that if load is required to increase in a particular area, then we have to just install another transformer in parallel, whatever the existing transformer in previous one of whatever the power rating of that particular transformer. Okay, so if a particular area load increases, then we require to connect the other transformer in parallel. Okay, or otherwise we can say that the power supply we are able to frequently more reliable if we supply through a parallel operated transformer, that means 2 or 3. Okay, so these are the basic advantage if we connect the two transformer in parallel. Okay, so today experiment name is the parallel operation of the transformer. Okay, so just allow him. What is the condition for connecting two transformers in parallel? Have some specific condition, is it not? If you want to connect two transformers in parallel, then must be satisfy some criteria. So first of all, tell me what is the condition for two transformers connected in parallel?
Sir, same frequency rating,
Same frequency rating,
same polarity,
same polarity,
and same kVA rating,
same kVA rating,
same phase sequence,
phase sequence,
same voltage ratio and turn ratio.
exactly. So these are the some condition which must be satisfied if we connect two transformer in parallel. Okay, that means same voltage ratio, or you may say that the voltage is directly proportional to number of turns. So you may be also say that the number of turns ratio are the same. Okay, for the two transformer, and same percentage impedance, that means XYR ratio, and power rating, that means same kVA rating, or vector groups are same and some polarity is same polarity and same phase sequencer. So these are the condition satisfy if you want to connect the two transformer in parallel. Okay. So experiment name is parallel operation of three-phase transformer. So first two conditions you have to require. Either here why we require to connect to the two transformer in parallel and what is the condition for the connecting two parallel transformer in parallel. Okay. So we already discussed these 2 points. That means why we require to connect some transformer in parallel and what is the condition that you have to keep in your mind when you install the two transformer in parallel. Okay. So I think is it clear to all of you to this point? Okay. Hello.
Yes, sir.
Okay. So why we require to connect the two transformer in parallel and what are the condition for connecting two transformer in parallel? Okay. Just these are condition why we require to explanation some voltage ratio and turns ratio that will be not going to discuss here. You already study I think in electrical machine too. This explanation also. Okay. So if you go through the recall, if you uh, study in previous semester, then you maybe recall that one. Okay. So first condition is the same voltage ratio or turns ratio. That means if the transformer connected in parallel have a slightly different voltage ratio, that is not maybe you often practically same. Okay. Then due to the inequality of induced EMF in the secondary winding. So if that means induced EMF in the secondary winding, circulating current will flow in the loop formed by the secondary winding under the no load condition. So which may be much greater than the normal no load current. So the current will be quite high as the leakage impedance is low for the transformer. When the secondary winding are loaded conditions, with that so this circulating current will tends to produce unequal loading on the two transformer. Okay. And it may not be possible to take the full load from this group of two parallel transformer. One of the transformer may get overloaded or one of the transformer may be underloaded. Okay. So if the two transformer of different voltage ratio are connected in parallel with same primary supply voltage, there will be a difference in the secondary voltage. So now when the secondary of these transformer are connected to same bus, because two transformer you already connected in parallel, and primary side of these two transformer you have just connect from the same supply, and whatever the secondary terminal of the two transformer you have to just connect through a bus where you want to supply given to the load. Okay. So that means a circulating current will flow, okay, due to the EMF difference in the secondary winding of the transformer. Okay. So this circulating current, if you can avoid if you choose the same turns ratio of the transformer, so that the secondary side of the transformer EMF induced of the transformer is same one. Okay. So the main reason is for the same voltage ratio or turns ratio is to avoid the circulating current in the transformer. Okay. And second one is your same percentage impedance and reactance by ratio or resistance ratio are same of these two transformer where you want to connect in the parallel. So in parallel with the similar per unit impedance, they will be mostly share the if two transformer connected in parallel with similar per unit impedance. So they load in the ration of their KVA rating. Here load is mostly equal because it is possible. Okay. So per unit impedance, but if you connect two transformer who have the different leakage reactance to resistance leakage reactance to resistance ratio, then in this case the line current will be less than the sum of the transformer current, and the combined capacity will be reduced accordingly. So you just avoid this one and choose the same leakage reactance to resistance ratio of leakage reactance to resistance of the two transformer. So in the reactance value to resistance value of the per unit impedance result in a different phase angle of the current carried by the two parallel transformer. So you can avoid this one, okay, and select the same XYR ratio, that means leakage reactance to resistance ratio or resistance of the two transformer you want to connect in parallel, okay. And next one is the polarity. Okay. So polarity of all the transformer running in parallel should be same, otherwise hex circulating current again flow in the transformer if you not connected in proper polarity of these two transformers. Okay. So but no load current will be fed from these transformers. So if the instantaneous direction of the induced secondary EMF into transformer are same, when same input power is fed to the both of the transformer. So the transformer are said to be in the same polarity. Okay. So third point, you just try to concern when you just connect the two transformer in parallel. Just try to same polarity of the primary and secondary side you have to connect. Okay. So that the circulating current you can also avoid in this case. So polarity of transformer means the instantaneous direction of the induced EMF in the secondary. If the instantaneous direction of induced EMF in the two secondary in the two transformer are in opposite to each other, then same input power is fed to the both the transformer. So the transformer are said to be opposite polarity. Okay. So just try to concern about their polarity. Primary side polarity and secondary side positive and negative terminal of the transformer. Okay, and maybe phase sequence, that means three phase transformer has so three phase RYB or maybe represent by ABC, whatever you maybe want to represent. Okay, so their phase sequence, that means RYB in the primary and secondary, also you just mention. Okay. Fourth condition, that means the same phase sequence. Next one is the same phase angle shift, that means zero relative phase displacement between the secondary line voltage. So you have to concern about which group are connected in parallel. Okay, because we want to same phase shift in the secondary side line voltage. Okay, so the group 1, that means group 1 YY0. Okay, you maybe say that the phase shift between the primary and secondary line voltage is 0. Okay, and what is the Y, capital Y and Y represent here? Capital D and a small d.
Sir, high voltage side and low voltage side, sir.
High voltage side transformer winding, that means connected in either capital letter denoted by high voltage winding connection, and the small letter means particularly maybe either a small y or a small d, that is represent the secondary side winding connection, and 0 and 6 and 1 is what is the mention by this one, 0 6 1, that means 0 6 and 1. So have you go through the phasor diagram of the three-phase transformer? Okay, so I think you all are familiar with the 6Y and 11. So zero phase displacement, that is represented by here 0 in suffix 0. Okay, and group 2, phasor group 2 represent the 180 degree, that is either maybe primary side line voltage and secondary side, and this represents secondary side, that means in opposite direction. Okay, 6, that means our indicator at the 6 and minute of clock represent at 12. So you will find out the phase displacement is 180 degree in group number, phasor group number 2. Okay, so that is represented by YY6, is it not? YY6, that means phase displacement is 180 degree, and in group 3, that means minus 30 degree phase displacement. So hour and minute candle are represented by phase displaced by minus 30 degree. Okay, and this one is for plus 30 degree, that means YD1. Okay, so phase displacement of the secondary side of the line voltage, that means the transformer, in order to have zero relative phase displacement of the secondary side line voltage belonging to the same group, can be parallel. So these are the fifth condition required. That means same phase angle shift. Okay, same kVA rating. That means if two or more transformer is connected in parallel, then load sharing percentage between them is according to their rating of the transformer power rating. That means power rating. So if all are the same rating, they will be share equal loads. Okay, suppose that at the initial condition 25 MVA transformer already installed, and then after some times when load increase in a particular area, then you require to install another 25 MVA transformer and connected both the transformer in parallel. Okay, so their load share between these two transformer is equally, and if kVA rating is changes, that means of the two transformer, so their load sharing percentage is also changes with their according to the kVA rating. Okay, so the transformer of unequal kVA rating will share a load practically, but not in proportion to their rating, providing that the voltage ratio are in identical and the percentage impedance at their kVA are identical or very nearly. So the very nearly these two transformer rating, kVA rating, are same. So in this case, a total of 90 degree of the sum of the two rating is normally available. So it is recommended that the transformer, the kVA rating of which differ by more than 2:1 should not be operated permanently in parallel. Transformer rating, one is suppose that 300 and another is suppose that 100. So these are may not be able to connect in permanently parallel. So transformer having different kVA rating may operate in the parallel with load division such that each transformer carries proportionate share of the total load to achieve accurate load division. So it is necessary that the transformer be on with the same turns ratio and that the percent impedance of all the transformer be equal impedance. Okay. When each percentage is expressed on their per unit kVA base. I think all of you familiar with the per unit system. Per unit system हम लोग कैसे represent करते हैं quantity, electrical quantity? How you can represent the any quantity in per unit? पर यूनिट में हम लोग कैसे रिप्रेजेंट करते हैं? किसी को ध्यान नहीं है पर यूनिट का डिफिनेशन? एक्चुअल वैल्यू बाय बेस वैल्यू. Per unit is nothing but the actual value to the base value. Okay. So किसी भी ट्रांसफार्मर का यदि हम लोग ऑल पैरामीटर्स यदि पर यूनिट में रिप्रेजेंट करना चाहते हैं तो हम लोग कैसे रिप्रेजेंट करते हैं? एक पर्टिकुलर उसका जो रेटेड वोल्टेज या रेटेड पावर रेटिंग है उसको बेस एज्यूम करके और उस पर हम लोग रिप्रेजेंट करते हैं इन पर यूनिट. ओके. सो per unit quantity represented on a particular base kV and base voltage. Okay. That means actual value to the actual value to the base value of any quantity, either it may be voltage, current, or resistance, primary side resistance of the transformer, secondary side resistance of the transformer, primary side reactance of the transformer. तो कोई ट्रांसफार्मर सपोज करो दिया हुआ वोल्टेज रेटिंग दिया हुआ उसका पावर रेटिंग दिया हुआ है रेजिस्टेंस उनको दिया हुआ है प्राइमरी साइड का उसको कन्वर्ट करना है पर यूनिट में तो कैसे फाइंड आउट करेंगे रेजिस्टेंस को एक्चुअल वैल्यू ऑफ द रेजिस्टेंस टू द बेस वैल्यू ऑफ द रेजिस्टेंस इन द सेम यूनिट. ओके. तो यदि हाई वोल्टेज साइड का पर यूनिट में कन्वर्ट करना है तो हाई वोल्टेज साइड का हम लोग बेस इंपीडेंस फाइंड आउट करना पड़ेगा नहीं. तो हाई वोल्टेज साइड का यदि बेस इंपीडेंस फाइंड आउट करना पड़ेगा कैसे फाइंड आउट करेंगे? एक पार्टिकुलर हम लोग सबसे पहला काम क्या करेंगे बेस केवीए रेटिंग चूज कर लेंगे ट्रांसफार्मर का ऑन दी हाई वोल्टेज साइड और लो वोल्टेज साइड यदि हम लोग फाइंड आउट कर रहे हैं हाई वोल्टेज साइड सपोज करो तो हाई वोल्टेज साइड हम लोग क्या करेंगे केवीए रेटिंग जो होगा रेटेड उसको हम लोग बेस कंसीडर करेंगे और हाई वोल्टेज साइड का जो वोल्टेज रेटिंग होगा उसको हम लोग बेस वोल्टेज रेटिंग कंसीडर करेंगे एंड देन अकॉर्डिंग टू दैट जस्ट फाइंड दी बेस करंट ऑन दी हाई वोल्टेज साइड. बेस करंट क्या हो जाएगा पावर रेटिंग दैट मींस केवीए बाय वोल्टेज. वहां से हम लोग बेस इंपीडेंस फाइंड आउट कर सकते हैं ऑन द हाई वोल्टेज साइड. सो हाई वोल्टेज साइड दैट मींस एक्चुअल रेजिस्टेंस टू द बेस इंपीडेंस that can be represented in per unit. Okay. So that is mentioned here. It is necessary that the transformer be owned with the same turns ratio and that the percent impedance of all the transformer be equal when each percent is expressed on the kVA base of its respective transformer. Okay. यानी उसके kVA base को कंसीडर करके हम लोग पर यूनिट में कन्वर्ट करेंगे उसका इंपीडेंस को. ओके. ये चीज ध्यान में रखना है तुम लोग. ये चीज तुम लोग बहुत पहले भी किया होगा. And these are the advantage that means we already say that the maximum electrical system is efficiency and maximize electrical system availability condition and maximize power system reliability. We already explained at the starting point of this lecture. Okay. So what is the apparatus required to perform this experiment to transformer? Okay. So that means you have to require at least 2 transformer. Okay. The parallel operation हम लोग लैब में परफॉर्म करने जाएंगे. So what are the apparatus required to perform this experiment? क्या क्या जरूरत पड़ेगा? 2 transformer, not, and voltmeter, ammeter. Whatever if you want to measure the primary side voltage of transformer 1 and transformer 2 transformer you have to require for connecting parallel and their primary side and secondary side voltage and current measurement. That means voltage and ammeter required. Okay. So this is the connection diagram of the two transformer connected in parallel. That means transformer 1 and 2, their KVA rating may be 2 kVA. We just consider transformer 1 and transformer 2. KVA rating is 2 kVA, and voltage you may be consider 415 to 415 volt, and 50 Hz frequency. Okay, and voltmeter and ammeter required according to measurement for the primary side and secondary side current and voltage. Okay, this is the sequence. Now, what is the procedure for performing this experiment? What is the general procedure of performing any experiment? Can you explain, or if you discuss about particularly this experiment, that is parallel operation of two transformer? What is the general procedure? First of all, you have to, any experiment you have to connect according to their circuit diagram, is not? So first of all, just connect the circuit diagram, connection all the instruments, that means voltmeter, ammeter, and primary winding, secondary side of the transformer. Okay. So these are the general procedure. That means one connect the primary side of the transformer 1 and transformer 2 sequentially as per the circuit diagram, that is connect with RZ, and Y connect with Y, Z, and B connect to B2. Okay. So open the secondary side terminal, both of the transformer except neutral point, and short the neutral point of the secondary side. Connect 1 voltmeter across R, Y, and B, and 1 voltmeter across the R2 and RY. Okay. And switch on the supply. Next, note down the voltmeter reading of the primary side, both of the transformer, and next step is your note down the voltmeter reading of the secondary side of the transformer. Okay, switch on at the no load condition, and connect another voltmeter, say V2 across RI and R, both of the transformer accordingly. Maybe connect another voltmeter across B and V2. Okay. So switch on the supply and observe the reading of the voltmeters. If they have no reading, then we can consider that the phase sequence of the transformer are same. Okay. Similarly, you check the voltage across B and B, or CI and C, and the voltage also be 0. So this is the observation table for performing this experiment. That means the primary side connected in delta and secondary side in a star. Okay. So you will find out their connection in the primary and secondary. Yeah, secondary side in delta and primary side in a star. Okay. So according to the circuit diagram, you have to just connect the voltmeter, ammeter, and supply of the transformer 1 and 2. Okay. So you just make the circuit diagram. What you have to note down when you perform this experiment in the lab, just we will perform this experiment in the next class. That means started from 4 p.m. Okay. So just join. We will go to the lab and just try to perform this experiment today also. Okay. So you just make it the observation table, and when we will perform this experiment in the laboratory, so you are able to note down the reading, whatever the primary and secondary side reading indicate on your voltmeter and ammeter. Okay. So just everyone just make it table. Hello. Hello. टेबल तुम लोग बना के रख लो, उसके बाद हम लोग नेक्स्ट क्लास में हम लोग लैब में जाकर के एक्सपेरिमेंट करेंगे। बना लिया है टेबल?
बना रहे सर।
बना लो टेबल, जस्ट बना के रखो।
हो गया सर।
हो गया। So this one is for this same that means at the load condition, when you apply the load on the secondary side of the transformer. Okay, so procedure is same, I think, and you have to make the another table for the load condition. Okay, one for no load and just another table for the load condition. You have to just make two table. Okay, and I think note down the voltage and current both of the transformer in both sides and switch on the load. Okay, so just to make one table for the no load and another table for the load. Okay, so procedure is same as the previous one. That means for the no load up to this point, that means up to fourth, you know, and up to fifth, and in sixth when you apply the load, so in the secondary side just apply one step in a step. So various type of load can be connected in the secondary side of the two transformer. Okay, and every step note down the reading of the voltmeter and ammeter. So just make two tables, so one for the no load and one for the load condition. Have you make it? Hello. सर्किट डायग्राम ध्यान में रखना चाहिए, टेबल दोनों रहना चाहिए साथ में। टेबल कंप्लीट हो गया ना दोनों? हेलो हेलो, टेबल एंड सर्किट डायग्राम दोनों कंप्लीट हो गया ना? रिस्पॉन्स नहीं कर रहा है। हेलो